Alright, for the short break. Number 1, you needed to find the range. So this is similar to the last one we did where we had to find the domain. So the order pairs are the same. We're just now looking for our y values. So as you look at all of your y values, some of them repeat. Remember when we list these out, we don't list the repeating ones. We just list least to greatest the numbers you have. So -5, -3, -2 would be your answer for number 1. If you have repeats, you get rid of those. Questions on number 1? Number 2, this one asks how many solutions does this have? So as you start to solve this, you distribute and combine like terms. You end up with the same thing on both sides, even though they look a little different. So 3x plus 6 is the same thing as 6 plus 3x. They're just switched. If you notice that, you could stop there and say this is infinitely many. Or if you didn't realize that, you could keep solving. Subtract 3x on both sides. We're left with just 6 equals 6, which is a true statement, so that would still be infinitely many. What questions do we have on that one? For number 3, you needed to solve this equation for y. Move x by adding it to the other side. And then divide everything by 3. So you would end up with y equals 1/3 x minus 1. Any questions on that one? Then on the back, so number 4, we needed to solve the equation. It was a proportion, so we needed to cross multiply. After we cross multiplied or multiplied diagonally, we need to distribute on both sides. Pick what you want to move and move it. And then divide, and you should get x equals -2. What questions on that one do we have? And then the very last one asks what the domain of this graph is. Because this is not a bunch of random points, this has to be in a certain notation, either set builder or interval notation. So in set builder notation, with all of your inequality symbols, it would be from left, furthest left to furthest right. So from -3 to +1, or -3 is less than or equal to x, which is less than or equal to 1. That means it starts at -3, ends at 1, but it's also everything in between there. Or you could use your square brackets to do the same thing. Starts at -3, ends at 1, and it's everything in between. Any questions on 5? So you all should have new notes in front of you that look like so what we've done so far, we factored by GCF, we factored by grouping, using GCF but doing it twice, factoring by difference of squares or DOS, to find when you have perfect squares, to include finding GCF and then finding difference of squares. This is not really any of those. This is a different type of factor. So as I mentioned before, this may be new to you, it may not be, but everyone should be paying attention. That way everyone fully understands. This one has a specific rule that we have to remember. 1, it will be in this format. x squared plus bx plus c. Really, it's in the form of ax squared, but your a value is 1. So you need to know that anytime this rule applies, it's going to look like that. If it doesn't look like that, this rule doesn't apply. Okay. When we go to factor this, we need to find two numbers that multiply to be c, but add to be b. So whatever numbers we find, they have to go together. But that rule has to stay the same all the way through. We can't switch them. What we can change a little is you may be subtracting to find b instead of adding. So that might be switched. But that depends on the value of c. Now, that rule may not make sense until we do some problems, so let's actually do some problems. With these, you have to be really good with your factors. So what I would suggest for every single problem, unless you know them like the back of your hand, which I don't even know sometimes, list out all of the factors for 12 and then go from there. So we need to find two numbers that multiply to be 12, but add to be 7. You may be thinking it in your mind or not, but let's list them out. Factors of 12. 6 and 2. Smarter, you guys. 7, 3 and 4. 1 and 12. So because we know we're looking for two numbers that multiply to be 12, it has to be one of these pairs of numbers. I can't choose like 1 and 2 or 3 and 12. It has to be one of the set pairs. Of those pairs, which ones would add to be 7? 3 and 4. So what I would do is, if 12 is positive and 7 is positive, that means basically, if they're both positive, then both of your answers have to be positive. We'll deal with things that are not that case. So when we write our factors, there's going to be two sets of them. Each of these problems will have an x in the beginning. Let me make this a little smaller. Each factor will have an x. And then the two numbers you just found with their signs will go in. It does not matter if I put plus 3 here or plus 3 here. But I need to have them both. Just like when we were doing our difference of squares, to check to make sure this works, we could distribute this back out. So we're going to do that. X times x would give me x squared. X times 4 would give me 4x. Three times x would give me 3x. 3 times 4 would give me 12. And then I could combine my like terms. My middle terms would add to be 7x. And that's how I know I did this right. For difference of squares, I said it's not really necessary. For these ones, it's not really necessary, but you may want to check some of them. But for the next one, I would definitely recommend double checking all of them. Do we have any questions on that one so far? Let's try number 2. Same thing. We're looking for two numbers that multiply to be 20, but add to be 9. So, factors of 20. 4 and 5. 4 and 5. 10 and 2. 20 and 1. Of those factors, which would add together to be 9? 4 and 5. Now again, you may realize that without doing the factor tree, and once you get the hang of this, that's fine. The factor tree is not necessary for all of these problems, but it will also help you. This is not x, this is n. Be careful with your variables because they will change. They may not always be x. But whatever it is, it will be, the variable will still be first. I'm not going to distribute this one out, but I'll do the next one. Do we have any questions on this so far? Let's skip down to number 6. So for number 6, we need two numbers that multiply to be 1 and add to be 2. What times what gives you 1? 1. So in this case, the factor tree is not really necessary because it only has one pair of factors. And if we were to add those two together, 1 plus 1 does give us 2, so that's y plus 1, y plus 1. When you get the exact same thing, you could simplify this. Say y plus 1 squared, that's the same thing. If I were to distribute this back out, y times y gives us y squared, y times 1 gives us y, 1 times y gives us y, and 1 times 1 gives us 1. So we would have y squared plus 2y plus 1. So that does it. So if we have a positive and a positive, both of our numbers are positive. But when we have a negative and a positive, that changes things. So on number 7, I'm going to go ahead and make my factor tree again, and then we'll talk about what happens with the negatives. So now we need to multiply to a negative 18 and add to a positive 3. What are some factors of just 18 for now? We'll deal with the negative in a minute. 6 and 3. 2 and 9. So now that this is negative, our answer, in order to multiply to be a negative, one of our answers has to be negative. So now we have to figure out which pair and which one. If I did negative 6 and positive 3, would that give me positive 3? Negative 6 plus 3? No. If I did 6 and negative 3, would that give me positive 3? Yes. And had we rearranged this, we probably would have went through the others. You could do that really fast. -2 plus 9 is not positive 3. -9 plus 2 is not 3. -1 plus 18 is not 3. And -18 plus 1 is not 3. So basically, we eliminated those because we went with our first choice anyway. So make sure that you keep your negative and positive. Don't switch them, is what I'm trying to say. My brain, the words were not there. So when we write these factors, we would have n in both. Does not matter if I put -3 first or second. But you just need to have both. Before we distribute this to check it, what questions on this do we have? Be careful, especially with your negative ones. If you put 2 negatives, you will end up with something different than what you should have gotten. If I multiply this back out, we get n times n, which is n squared. N times -3 is -3n. And then I multiply the next set. 6 times n gives me positive 6n. 6 times -3 gives me -18. And when I combine these two, I do get n squared plus 3n. Thumbs up if this is making sense so far. Sideways if it's kind of making sense. Down if it's not making sense at all. Okay. Okay. Let's do 10. Your factor trees are also helpful if you get really big numbers that have a bunch of factors, because there could be, you might think, oh, it has to be these two, but it doesn't work. So for number 10, we need two numbers that multiply to be 54, but add to be 3. What are some factors of 54? You may need to start dividing if you're not sure. 54 divided by 2, 54 divided by 3, divided by 4. Keep going.
Two and 27.
2 and 27. 3 and 18. And 9. And then 1 and 54. There are also some ones when you do this, you could eliminate easily. No matter how I make 1 and 54, if I make one of them negative, doesn't matter the way I do that. They're not going to equal 3 regardless. They're way too far apart. So I can get rid of those. 2 and 27, same thing. No matter how I make that negative, when I add or subtract them together, they're not going to give me 3. Same thing with 3 and 18. 3 minus 18, 18 minus 3, that's not going to give me a positive 3. 6 and 9 definitely would. We just have to figure out which one. So would this be -6 or -9 to give us positive 3? -6. 2. have s minus 6 and s plus 9. When you have a negative, when you have a positive and then a negative, where your middle term is positive and your last term is negative, the two numbers you find, the smaller of the two is always going to be negative. So there are like rules within rules for this. So if they're both positive, yeah.
That's your fun.
Yes.
Oh, I was like, you're
I'm gonna make them different colors. I don't know if that'll be better. No, it's okay. My handwriting is sloppy. Yes. As soon as she gets back. So if it's plus and then plus, everything is plus. If it's plus and then minus, the two numbers you find, the smaller number will be the negative. So you can probably assume what the other rules of this would be if you have minus and then plus, or minus and then minus. On this page, you don't have examples that are minus and then plus, but you do on the practice page, so we're going to jump to that. And we're going to do number 7 and 8. So it's on the back. Okay. So for 7, we're looking for two numbers that multiply to be 8, but add or subtract to be negative 6. Factors of 8. 4 and 2. Those are going to be the one that work, because 1 and 8, no matter how I add or subtract, that would not. However, if our 8 is positive, and we have to multiply it to be positive, that means our two answers either have to be positive or both have to be negative. So in order to get negative 6, these would both need to be negative. So we'd have y minus 4 and y minus 2. So both positive, both of your numbers are positive. Positive, negative, the smaller number is negative. Negative, positive, they're both negative. I'm going to distribute this back out so you see what happens. So which part did you get lost at? About the two negatives, you said? So we know that in order to multiply to be a positive, it either has to be positive or both negative. We can't have a positive times a negative because that would give us a negative, right? Because this is positive, we're looking for two numbers that are either both positive that would add to be 6, but it's negative, or both negative that would add to be negative 6. Okay. So 1 and 8 would not work, positive or negative. 4 and 2 would not work if it's positive, because that would give us a positive 6. But 4 and 2 would work if they were both negative. But that would give us a negative 6. Which is a problem. Great. So I'm going to distribute this out real fast. Y times y gives us y squared. Y times negative 2 gives us negative 2y. Negative 4 times y gives us negative 4y. Negative 4 times negative 2 gives us positive 8. So we would have y squared minus 6y plus 8. There were a couple of you that did this. 0, 1, 8, 14. Carter and Tyson.
Thank you.
Uh-huh. We're going to do one more group and then we'll be done for today. And we'll finish the rest on Monday. For number 8. Yeah. It's similar setup. It's a minus and then a plus. So we need to find two numbers that multiply to be 28, but add to be 11, or subtract to be 11. Without me writing the factor tree, can anyone tell me what those two numbers would be? 4 and 7, positive or negative? Both of them would need to be negative. Okay. Again, you could still write out your factor tree. Your factors would be 1 and 28, 2 and 14, and 7 and 4. Be careful because you may, when you write out your factors, be thinking 2 and 14, but that doesn't give you 11. But 7 and 4 would. So on Monday, we're going to talk about the last type of problems when you have a negative and a negative, and then you'll have time to practice all of these. I did move the Khan Academy on this to be due next week. The ones that are due today are just the difference of squares ones. So the difference of squares intro and the difference of squares. Make sure you do those. If you haven't done the Delta Math, make sure you do that. Practice that. And then come see me, not after school today, but starting next week as soon as possible with any questions you may have.